Hello everybody, today I will present to you information about electronic circuit. How to choose the component of electronic circuit. So as you see in the title of this formation, I will focus on the basic concepts that we will focus to choose the components used more in the circuit as the diode, the capacitor, resistor, transistor, PNP, NPN, and also the regulator. The function of this example, it's this circuit transform a variable continuous voltage 47 volt to 17 volt to a consistent voltage maximum 6 volts, and we can control the value of this voltage by this variable resistance RV1. Of course, the goal of these projects is to give the student a basic idea how to choose the value and the type of the components that's most used in the electronic circuit. So, as a plan to explain all the detail of this example circuit, I start by explain the resistor, transformator as two essential components, and so easy. And after diode, condensator, regulator, and finally the transistor. Before to explain how to choose the diode, I will explain briefly the choice of resistor and transformator. So for the resistor, the value of the resistor for an electronic circuit will determined by the relation U equal R multiply I. U the voltage across the resistor terminals in voltage, I the currents passing through the resistor in ampere, R the value of the resistor ohm. The characteristic to choose the transformator are input voltage or primary voltage, the output voltage or secondary voltage, the apparent power, and the secondary current. So this is all the characteristic that we consider when we want to choose the transformator. So let's explain all detail about the components of our circuit. So let's start. What will be the criticals to choose this diode? For example, so if you can constate here, we have a source of voltage 47 volt, 17 volts, and after the diode we have two components, the resistor and condensator or capacitor. So the factor considered in the fraction of diode is the capacitor. The capacitor keeps the voltage level in a period of time, and this is what will be control this diode. Because if we want to choose the diode, we should be careful about two indicates: the reverse voltage and the direct current. The current for our circuit is 10 milliampere. Now we calculate the reverse voltage. In the circuit, we focus to this capacitor and the source power. So suppose firstly that we applied 47 volts on anode of the diode. So the first situation, we have 47 volts in anode of the diode and 0 volt in cathode. So that means the diode is such as a closed switch, so the current can pass through the diode. After, we will have 46.3. That means the difference between the voltage of cathode and anode supposed 0.7. As I said, the capacitors keeps a level of voltage in a period of time. So that means the 46.3 volts must be in constant in a period of time. Now, suppose that in the first situation we have the switch of the supply from 47 volt to 17 volt. That means we have 17 volt in the anode and 46.3 in cathode. Now we have, in this situation, we have the diode is blocked. So that means the diode is such as an open switch. So in this situation, we can calculate the reverse voltage. It's 46.3 minus 17. So this is the first situation when we have the reverse voltage. We have other situation that it's a function indesirable and that's often happens in electronic circuits, that when we have the situation of on off, that means no supply. So in the anode we have 0 volt and in the cathode we have the 46.3 volt. So in this second situation we have the reverse voltage equal 46.3 volt. So in the between the two situations we keep the maximum voltage, that means 46.3 volt. So the reverse voltage will be more up than 46.3 volts, and of course the direct current must be more than 10 milliampere. So in the basis of the two situations, the situation of that the supplies switch from 47 to 17 volt, and the second situation when we have an interrupt of supply, that means we have in a period 0 volt in the anode of this diode. So we have the maximum voltage 46.3 volts, and for the current more than 10 milliampere. So let's test this in our software, Proteus. So if we pass to our software, Proteus, we have different type of diode. We select the rectifier, and as you see we choose I choose the diode that satisfy the two options of the direct current and the reverse voltage. So now we will pass to regulator. If you constate in the circuit we have as choice for the regulator LM317K. So why we choose this regulator for our example. So if we want to choose a regulator for a circuit, we must consider five criteria. So the first point is what the function of this regulator. That means it's a linear regulator or a regulator that we want to be as a switch. For our example, we want a linear regulator. That means a regulator that the input or the output of the regulator follow the change of the input. So this is the type of regulator that we need for this example. For the second type is the regulator is considered as a switch. So for the 2 point essential for our example to consider is to specify the current output of the regulator and also the input and output for regulator voltage. So that means we focus more about the current output of the regulator as an indicator to choose our regulator. And sometimes we consider also the input and output regulator voltage. Of course, in some activities there are some other criteria as the temperature. The temperature is considered mostly in the domain as electronic vehicle domains, because we have more time the elevation of the temperature of the components suddenly, so that influences the function of the regulator. So in this case the regulator must support the degrees of higher temperature. Also, this is the activity where we have more frequency than the principal frequency that's supported in all the circuits. So here we talk about the factor of sensitivity and the noise. So that's the capacitors connected to the regulator must be able to protect the regulator from the noise generated in the circuit. So this is general for generally how to choose the regulator. So let's apply our factors in the software. So we choose the convenient regulator for our example.